Hi, so let's talk about one-sided limits today. Majority of us probably familiar with definition of one-sided limits. Just a quick recap. As you can all tell by the definition, limit as x approaches to a from the left-hand side. Function is equal to limit. The value here we're gonna figure it out, and the second definition represents x as a the limit of this function as x approaches a from the right-hand side to find the limit of function. Okay, just to okay, let's just do a quick problem to see what we are trying to state here. Let me just make a quick graph. You can also see this example in your book as well, probably. Calculus first year. Here's the function y is equal to gx. Okay, so you're probably gonna see questions like this in your homework or your test. For example, find the limit as x approaches to 2 from the left hand side of this function gx, or similar like limit as x approaches to 2 from the right hand side, or c, find the limit as x approaches to 2 of this function gx. Okay, so how are we gonna look at this kind of problem? Okay, as you can tell from the graph, here this function gx, right, as x trying to approach 2 from the left side, negative denotes here the left side, which is this side, and this is the right side of the graph, right? So as you can already tell, as x approaches 2 from the left side, it's the limit for this function is 3, right? As x approaches 2, sorry, my graph is a little off, um, but like, sorry, but as you can you get the idea, right? As x approaches 2 from this side, the limit for this function is equal to 3. However, when x approaches 2 from the right hand side, you can tell the limit for this function is 1. And now if we try to find the limit of for this function as x approaches to 2, you can see, right, the limit does not exist. Limit does not exist. And this also helps us to compare the definitions, the standard definition of limit versus the one-sided limits. And you can clearly see this, right? The limit exists as x approaches to a for such function if and only if the limit of the limit as x approaches to a from the left hand side and limit as x approaches to a from the right hand side are equal. And you can also, and this is where it comes, you can apply this principle, right? For example, if you try to find a limit as x approaches to 5 from the left hand side, it's 2, right? Is 2. And if we see the limit for this function as x approaches to 5 from the right hand side is also 2. So this clearly helps us state if we try to find the limit as x approaches to 5 for this function gx is equal to 2 as well, based off this definition, right? If limit for such function from the left hand side is equal to limit from the right hand side, then we conclude that the limit for that function around that value is equal